10. Evaluate the antiderivative of x to the fifth divided by the square root of 16 plus x squared. Square root of 16 plus x squared, square root of a squared plus x squared. This very strongly suggests a trigonometric substitution. And the one that would make sense here would be x equal to 4 tangent theta. When we fill in the information here, so that would be dx would be 4 secant squared theta d theta, and square root of 16 plus x squared ends up as 4 secant theta. So let's go ahead and make all of those replacements here. So this is going to end up as the integral of 4 tangent theta to the fifth times dx is now 4 secant squared theta d theta, and this is 4 secant theta. Okay, so a lot of things are going to cancel here. What all cancels? Those 4 cancels, 1 power of secant cancels, and we end up with 4 to the fifth. That's a constant we can move outside the integral. And tangent to the fifth theta times secant theta d theta. So here, we now have to figure out how to integrate this. We're going to want a substitution. We can try either u is equal to tangent theta or u is equal to secant theta. As it turns out, the only one that works here, works nicely anyways, is u is equal to secant theta. Du is equal to secant theta tangent theta d theta. So we're going to want to split off a factor of secant theta tangent theta and rewrite everything else in terms of secant theta. So 4 to the fifth times the antiderivative of tangent squared theta squared secant theta tangent theta d theta. So tangent to the fifth became tangent squared is tangent to the fourth, and one more factor of tangent theta. So this right here is going to be our du, and tangent squared theta squared is equal to secant squared theta minus 1 squared. So this is going to be u squared minus 1. So after we make all of these substitutions, we end up with u squared minus 1 squared du, which is, so 4 to the fifth times the antiderivative of u to the fourth minus 2u squared plus 1. And so this is going to give us 4 to the fifth times u to the fifth over 5 minus 2/3 u cubed plus u plus c. Okay, so we see here u. And so we should know u is equal to secant theta, so we should know that we have to substitute back in to get rid of the u. So it's 4 to the fifth times secant to the fifth theta over 5 minus 2/3 secant cubed theta plus secant theta. But this still isn't good enough, because our original problem wasn't in terms of thetas, it was in terms of x's. And so in order to substitute back, secant theta is equal to square root of 16 plus x squared, all of that divided by 4. So everywhere we see a secant theta, we're going to replace it with this expression. I was able to just do it by looking right here at this line. Of course, an alternative way to come up with this would have been to draw the appropriate triangle here. And so because x is equal to 4 tangent theta, that's tangent theta is equal to x over 4. So x over 4 square root of 16 plus x squared. And from this, we can read off secant theta. So the very last thing to do here is just to make that substitution. So it's going to be kind of long and messy, but straightforward. Hit my camera on the way down. 1/5 times the square root of 16 plus x squared divided by 4, all of that to the 5th, minus 2/3 the square root of 16 plus x squared over 4, all that cubed, plus square root of 16 plus x squared, all of that divided by 4, and all of that plus c.